So this is part 2 of the Trig U substitution video series. This video is just going to be examples. What I have found is students are more comfortable after they get to see a variety of these. So we did 4 in our last video, including some explanation. We're going to do 8 in this video without the explanation in the beginning being necessary. So again, our goal is to figure out what does U need to be. And sometimes with the trig, it's a little more work than the polynomials because it may not be obvious. You may try to let U be something and realize it just doesn't work out that way. So you've got to try something else. I will say that you'll never get a problem that's impossible. So if at first you don't succeed, try again. So for this one, you only have a single trig function. You only have sine. So U has to be the angle. These are a little more limited. So when I derive this to get my du, think of it as x to the negative 1 power. So you do power out front, power 1 less. So your du is negative 1 over x squared. You actually have that except for the negative. You have the negative 1 over x squared there. So it is just a negative adjustment. What's being done to it is it's the angle of sine. It's one of our basic trig integrals. The integral of sine is negative cosine, but it's already negative, so we end up with positive cosine of 1 over x. And again, you could take the derivative of that and get what you started with. Now, the next one's kind of an interesting one because we have two trig functions. Our angle is just x, so we're not going to be able to say that u is just the angle because the angle is not complicated in any way, shape, or form. So my u needs to be a trig function, but you do have a choice here. You could either let u be tangent or secant. One way is going to work and one way will not work. So I want to make sure you understand why we need to go one direction as opposed to the other. So the way that works here, u needs to be tangent. And the reason is because the derivative of tangent is secant squared. I couldn't go the other way because if I let u be secant, the derivative of that is secant tangent, and that's not really what I have. I have like a tangent squared. So here's my du, which is perfect, no adjustment. My u, my tangent, is being squared, so this is a power integral. So power 1 greater divided by that power, we get tangent cubed of x over 3 plus c. This is one of the first ones that you see that you kind of have a decision to make and kind of like one way will take you to a dead end and one way will get you there. And if you go to the dead end first, just try the other way. Next one's a little easier because it only has secants. We only have a single trig function as secant. Your u then has to be the angle. Well, the derivative of x over 3, just think of it as 1/3 x. The derivative of that is 1/3. Which I don't have in my integral. I actually don't have a constant or coefficient at all. So to get rid of that, I'm going to multiply both sides by 3. So this time we have a times 3 adjustment. And what's being done to it is it's being secant squared. It is the angle of secant squared, which is one of our known trig integrals. The integral of secant squared is tangent, so we get 3 tangent of x over 3 as my answer when I integrate. Next one's back to kind of an interesting one. So I'm not going to let u be the angle, again, because the angle is just x, replacing it wouldn't do anything. So I need u to be a trig function. This one, the choice might be a little bit easier because you'll notice that the sine is the one really having something done to it. It's being squared, it's in the bottom, while the cosine is just kind of there. So hopefully you realize that that means our sine should be our u. And it works out really nicely because the derivative of sine is cosine. Sometimes the ones that have the toughest decision in the beginning actually have the easiest finishing, which is nice. What's being done to u is it's in the bottom being squared, so it's a u to the negative 2 du. So we get u to the negative 1 over negative 1, which is negative 1 over u, which was sine, plus c. Now this problem could actually be done in a totally different way, and I want to mention it just in case you looked at this and thought, I wouldn't have done it that way. You could actually break this up into cosine over sine and 1 over sine. And the reason that helps you is cosine over sine is cotangent and 1 over sine is cosecant. That is actually one of our 6 trig integrals. It's probably the one that you're the least comfortable with because we use it the least, but it is negative cosecant x, which is the exact same answer as negative 1 over sine. So you actually get a different looking answer, but an equivalent answer. Next one has a little bit of flexibility, more than some of the previous ones. So the first thing you're going to notice is my angle isn't just x, it's 4x, which means potentially we could let the angle be u. However, then you realize it actually has two trig functions, sine and cosine. We can't integrate sine and cosine together. What that means is your u needs to be one or the other. Here's what makes this problem flexible. It actually doesn't matter if you let u be the sine function or the cosine function. They both work. I'm going to let u be sine simply because I know the derivative of sine is positive, and I hate working with negatives. So here's my u. My u is the sine of 4x. Now, when you derive sine, you do get cosine. You also have to derive the angle. So it's kind of like a mini chain rule within this u sub. So your derivative is actually 4 cosine 4x. I don't have that 4 in my original integral, so I'm going to have to divide, giving me a 1/4 adjustment. Here's might be the toughest question with this one, and it's actually super simple, and I think that's kind of what makes it tough. When you try to figure out what's being done to u, well, not much. Your u, which was sine of 4x, is just to the first power. This is your du. This is your u. So it is just a u du. So simple, it's hard. The integral is power 1 greater divided by that power. You still have the 1/4 out front, so you're actually going to end up with a sine squared of 4x over 8 plus c. You could definitely have done this question by letting u be cosine of 4x. The only thing you want to be careful with is the derivative of cosine is negative, so you would have a negative 1/4 adjustment instead of a positive 1/4 adjustment. What you can't do with that one is you can't let u be the angle, because then you would be left with sine u cosine u, which is not something we can integrate all at the same time. So the next one has two trig functions, kind of like the last one. However, it has two trig functions that actually go together. Secant tangent is a known integral. This one, we can simply let the u be the angle, because when you do that, it is in a form that you know how to integrate. Now, the derivative of 3x squared is 6x. So we do have a 1/6 adjustment because we don't have that 6 in my original integral. But when we look at what's being done to it, it's the angle of secant tangent altogether, which is kind of long, but it's actually one of our known integrals. The integral of secant tangent is secant. So we end up with that 1/6 in front, and then the secant of my original angle, 3x squared. So I wanted you to see these two side by side. They both have two different trig functions, but they actually work out differently based on the trig functions that are there. I've got two left, so we're almost done with this video. I wanted to show you one. I think actually this number 11 is a little easier than what we've done, but it just has a different look. And then I'm going to finish with actually one of my favorite examples with secants and tangents combined. So the number 11, I think what makes this easiest is the U choice is a little simpler, because this one reminds me more of what you did in the previous lesson, where you have this entire piece that's being taken to a power. That entire piece needs to be your U. So my U is 2 plus sine theta. If you don't like thetas, you can write it as x. And then the derivative of that is cosine theta. Derivative of 2 is 0. Now you'll notice this 6, I don't really need it. It's not part of my du. So to kind of get it out of my way, it is perfectly legal to just bring it to the front of the integral. What's being done to you is it's being taken to the negative third power because it is in the bottom being cubed. So power 1 greater divided by that power. And then I'm going to clean it up. I can rewrite that instead of 6 over 2, I can write it as a 3. It is also negative, so I can write it as a negative 3. I'm going to move the u to the bottom. So that's 2 plus sine theta all 2, squared. And then tack on the plus c. All right, finally, our last problem. Our last problem is kind of an interesting one. I've actually seen this show up on multiple AP tests. I don't think the choice of u is difficult. The u needs to be secant, because there are two trig functions and secant's the only one that's having something done to it. You wouldn't let u be the angle because the angle is just x. So the derivative of secant is secant tangent. Here is the slight trick piece to this. When we go and say, well, what's being done to u? The temptation is to say, well, it's being taken to the fifth power because that's what I see in the original problem. It's actually not, because we have 5 secants here. One of them is needed for my du. So what I actually have is I actually have a secant to the 4th, because I'm kind of borrowing one of those secants to be part of the du. So that this is my u to the 4th, and this is my du. So that is why this question actually gets missed a lot, because students automatically see that 5 there and think, well, it must be a u to the 5th. It's actually a u to the 4th, because we need one of those secants to be part of my derivative. So I actually get u to the 5th over 5 when I integrate. So my final answer is secant to the 5th over 5 plus c. There are not a ton of trig integrals with u substitution on the AP test. I've actually think in recent years they've kind of gotten away from doing a lot of them. So what I did for an assignment, instead of doing a delta math, because I didn't really care for what they had there, I put together an assignment on AP Classroom that takes you through some trig, but it also reviews some of the things that you had to do yesterday. So it's more of an overall assignment for all of our u substitution integration.